Hello and welcome to today's VMware webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there is no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now I'd like to turn things over to today's presenter to get things started.
Good morning, everyone. This is Andrew Nielsen with VMware, and I'd like to welcome you to the Microsoft SQL Server Workloads on VMware Cloud on AWS webinar today, where we'll be covering design, migration, and configuration. A brief look into the agenda here before we get going. We're going to do some brief intros of our speakers today, which will be Oleg Ulyanov and Bill Jacobi. Oleg's from VMware, Bill is from AWS, respectively. We'll be doing an overview of VMware Cloud on AWS, and we'll be talking about migrating Microsoft SQL workloads to VMware Cloud on AWS. And then Bill's going to take us through VMware Cloud on AWS reference architecture for Microsoft SQL Server, and then we'll wrap it up and take any Q&A. But as we said before, we'd like to keep this as interactive as possible, so please put your questions into the Q&A window as you feel a need to do so. So a brief introduction about myself. I'm Andrew Nielsen. I'm the Senior Director for Workload Product Marketing with VMware and the Cloud Platform Business Unit. I lead all of the workload marketing efforts within VMware that covers everything from business critical and modern applications, as well as DevOps and machine learning and AI workloads. I've been in the IT industry for about 20 years across various Microsoft technologies, as well as security, and also within cloud, a lot of work with AWS. Oleg, you want to go next?
All right, thanks a lot, Drew, for the introduction. My name is Oleg Ulyanov, and I'm working for VMware in the same Cloud Platform Business Unit, and I'm responsible for SQL Server workload on VMware vSphere. And I have a rich background in the field working for VMware services for the last 7 years before spending some time with Microsoft. And during this call, I want to share my experience running and configuring SQL Server workload on VMware Cloud on AWS. And it's my pleasure to hand over to Bill, who will be introducing himself in a minute.
And hi, everybody. Thanks for joining. I'm Bill Jacobi, Principal Solutions Architect for Amazon Web Services. And I have been at Amazon for 5 years. Previously was at Microsoft for about 20 years in a range of roles, including on the SQL Server team. And I'm responsible for enterprise applications at Amazon, which includes all of the Microsoft applications running on Amazon, as well as running Microsoft applications on VMware Cloud on AWS. And so you can see a picture of me and my 2 Bernese mountain dogs. And I think I'll let Oleg take it from here.
All right. So thanks, Bill. Let's jump into a VMware Cloud on AWS overview. As we look at in the next 5 years, we are going to see more applications and solutions deployed than mankind has done in the last 40 years. However, these applications and workloads are changing. They are moving from end-tier applications to highly distributed cloud applications that support functions like advanced analytics, industrial IoT pushing out to the edge, a lot of business process automation, as well as self-service experiences, as well as data-defined business processes. And as these apps change, they need a platform that changes with them. And with that, we offer you VMware Cloud on AWS. So leveraging the partnership of the #1 private cloud provider in the software-defined data center with the #1 public cloud infrastructure provider of Amazon Web Services. And what that does is that allows customers to rapidly take their on-premises VMware infrastructure of vSphere, NSX, and vSAN and extend those technologies and those applications and workloads into the public cloud and being able to give them a global reach and presence thanks to the infrastructure of AWS. It also gives you operational consistency and security by extending those on-prem investments in processes and tools so that you don't have to retool or reskill. And more importantly, it also gives you access to native AWS services. So if you're moving various databases or other applications into the cloud, you can take advantage of services like RDS, Aurora, or any of the services in the AWS catalog. Now, this is our current footprint of VMC on AWS globally. By the end of this calendar year, we will be in every AWS region around the world except for mainland China, which is something that we are currently working on. But no conversation about moving to cloud is complete without understanding how VMware Cloud on AWS has a modern cloud economics discussion. So when you move to VMware Cloud on AWS and you're leveraging that investment that you've already made in VMware, there's no need to do application rework. So with our consistent infrastructure, you simply pick up your applications, in this case SQL Server, and you vMotion them into VMC on AWS. There's no need to reskill, so you don't have to go out and train up a special DevOps team. Those skills that you already have on VMware immediately transfer into VMC on AWS. Also, there's no workload locking. So if you want to move your workload from your on-premise data center into VMC on AWS, you can do that. You want to pick that workload up and move it back, you can do that too with no rework and no reskilling. And there's no need for repayment in the sense that as you go into the cloud with VMC on AWS, you only pay for what you use. You're not standing up brand new infrastructures. It is consumed as a service because the public cloud is available to all. And with our partnership with Amazon Web Services, we give you that global reach for those applications. So there are many customer-driven use cases around VMC on AWS, but there are really 4 primary ones that we see. One is data center extension. So that is taking your existing on-premises data center and extending that into VMC on AWS in the case of maybe test dev or burst capacity. There's also a very traditional use case, which is VR. So if you want to, instead of having a on-premises VR capability that you have to have CapEx cost for, you can move that to an OpEx model where you can basically spin up your DR environment on demand. There's a full cloud migration, which allows you to consolidate your IT assets and move everything into the cloud, further shifting that CapEx to OpEx transition. That could also be to avoid an infrastructure refresh, and you can do that data center wide. But there's also the ability to take advantage of next generation apps. So as we talked about in the previous slide with those access to native AWS services, you can take your application through a modernization process or do new application build outs that tie into your existing infrastructure. Now, these are some of the 4 use cases that we talk about. Now I'm going to transition this over to Oleg so that he can deep dive into what we're specifically doing with Microsoft SQL Server. Oleg, the floor is yours.
Thanks a lot, Thanks a lot, Andrew, for this brilliant introduction for VMware Cloud on AWS platform. Now, let us take a look at some specific for SQL Server workload on VMware Cloud on AWS, what we need to consider prior to, while, and after migrating to VMware Cloud on AWS, and how this fits to your SQL Server landscape. First, is very important to understand and structure your SQL Server workload that's going to be moved to VMware Cloud on AWS, because different tiers of your SQL Server workload will dictate different requirements. And tier 1 SQL Server workload, which is where you would expect to have high performance, high availability, that would probably dictate higher cost associated with that tier, because we want to ensure that best performance will be available for that SQL Server instances and databases. For tier 2 workloads, that will be a major part of a workload in your SQL Server estate. That is where we would be looking for capacity and cost savings. And tier 3, that is where consolidation will be your primary goal. And we can also use some overcommitment while planning resources inside of VMware Cloud on AWS. In addition to tiering your workload, it's very important to understand what kind of database workload will be migrated. It's a different requirement that will be dictated by online transaction processing, which is high number of small insights, input, output that will be sent by the relationship databases. And TPCE benchmarking might be used to simulate that workload prior to the migration. Online analytic processing, which is characterizing your SQL data warehouse, is having a requirement for high throughput. That is where your SQL will be reading, mostly reading, sometimes writing a big chunks of data with the requirement that your platform should provide a high throughput to that workload, and you can use TPC-H to simulate that workload. Special requirements will be dictated by business continuity, like backup, restore, or database refresh, where we are mostly will be dealing with sequential read and write. That is where understanding types of SQL workload to be migrated influence what platform and in what configuration should we choose to host this workload on VMware Cloud on AWS. Looking at the way how you would migrate your SQL Server workload, assuming that it's already running on VMware vSphere on premises, VMware Cloud on AWS provides a number of ways how we can actually execute this movement, including normal vMotion, which could be live or cold vMotion, where you will be doing it from vSphere client with a user-initiated single VM at a time, leveraging long-distance vMotion. And we recommend to use such approach for your very specific workload, for tier 1 application, or for special use cases like primary node or Windows Server failover cluster. More common way to migrate workload is to leverage hybrid cloud extension, or SCX, which provides you an ability to bulk migrate your workload or schedule your vMotion, which could be user-initiated or scheduled. Implementing SCX require design effort, preparation, but provides a lot of additional benefits, including L2 VLAN stretching and ability to schedule your migration. After taking a look at the approach to migrate SQL Server, let us go deeper into details for the design and configuration for SQL Server workloads on VMware Cloud on AWS. Looking at the reference architecture, that is where you can see that moving SQL Server workload to VMware Cloud on AWS provides you with a way to connect your on-premises data center with your VMware Cloud on AWS, forming a hybrid structure where your SQL Server workload can be simultaneously run on-premises and on VMware Cloud on AWS, consuming the same VC infrastructure based on vSAN and NSX, as Drew already pointed out. And in addition, it might be extended with native AWS services. That is where the second part of our webinar that they're going to deliver will go deep into detail for this integration with AWS structure. Preparing your workload migration is the vital part of the whole process, because good architecture in planning phase is what will ensure success of your migration. First thing first, before moving your workload, make sure that it's right size. Remember that oversized virtual machine hosting SQL Server workload, having more virtual CPU assigned that SQL Server workload is actually using, will perform worse as a right-sized workload with a lower number of vCPU assigned if that is required, also helping you to reduce number of licenses used for a SQL Server workload. Remember to collect all requirements, all technical requirements, all networking requirements that will be very important here, including your security zone placement, VLAN that should be extended to VMware Cloud on AWS. Ensure to have risk consumption constraint and risk mitigation plan while migrating your workload, followed by high-level architecture and logical design. And last but not the least, it's your operational consideration, because after creating hybrid cloud and moving your SQL Server workload, operational phase will be where you are spending most of your time, and we will cover this operational consideration in a later slide. Now let us take a look for some specific SQL Server workload configuration from VMware perspective. The same best practices apply that we are having on premises. For vCPU assigned to your VM, it's recommended to ensure that you're not using CPU hot flag, because that will disable vNUMA exposure to your VM. We recommend to recheck vNUMA topology that will be exposed to your VM, because you're moving from on-premises ESXi host, having its own vNUMA structure, to your AWS bare metal host, for example, i3 bare metal, having 2 sockets, 18 cores, and 1 vNUMA being 18 cores. So that means you might ensure that OVM having 18 vCPU assigned will fit to 1 virtual NUMA node. And check your reservation and limits. We recommend to use reservation if your SQL workload will run as a part of a general-based cluster, and we don't recommend to use limits at all. For memory, it's okay to use hot flag, and for most of the use cases, we recommend to set reservation for memory assigned to your VM, because SQL Server is very actively using memory, and if it will be some delays in serving memory for SQL Server, it might cause a big performance delay for your application depending on a database. Now let us take a look at network and storage. For network, VMAX Net 3 should be your primary adapter type that should be used for your VM hosting SQL Server workload. We recommend for most of the cases to use L2 VPN stretched port groups so that you wouldn't be doing re-IP while moving from on-premises to hybrid cloud. it could be configured either through L2 VPN client or STX, but should be prepared well in advance and tested before moving SQL Server workload. Storage is one of the major parts to ensure that your SQL Server workload will perform as or better as you have it on premises. Remember that for i3 host, your storage will be provided as VMware vSAN, and for R5 host, it will be EBS storage. For vSAN, we recommend to use RAID 1 and at least one failure to tolerate to all tier 1 SQL Server workloads to ensure best performance possible. PV-SCSI controllers could be used for your VM configuration. We are supporting up to 4 vSCSI controllers per virtual machine, and we recommend to spread your database between multiple VMDKs, with each VMDK is assigned to separate SCSI controller and then distributed evenly between them if it's more than 4. For any configuration that might require clustering that we also would touch after that, do not use SCSI bus sharing set to virtual, because that will prevent vMotion and it will pose your unsupported configuration. Let us take a look at high availability option. That is where what you have configured on premises. VMware Cloud on AWS allowing you to retain your high availability configuration for SQL Server workload that you configured on premises and add some native availability feature in addition to what you have. We always provide vSphere HA and all other vSphere high availability features as a part of VMware Cloud on AWS. And in addition to that, as a part of Stretch Cluster, you could also provide an additional availability if availability zone inside of VMware Cloud on AWS will fail. As mentioned, we support all major SQL Server native high availability options, including SQL Server always on availability groups. For availability groups, it's very important to mention that it's no support restriction, it's no special shared storage configuration required, it's just normal VMDK, as all the replication of traffic and data will be handled by SQL Server. And also it can be combined between on-premises and VMware Cloud on AWS, where you might have your primary cluster located on premises with an additional node located in VMware Cloud on AWS and leveraging asynchronous always-on availability groups configuration. One of the main differentiators for VMware Cloud on AWS is support for SQL Server failover cluster instance, which was enabled by support for SCSI-free persistent reservation on top of vSAN in VMware Cloud on AWS. For now, VMware Cloud on AWS is the only platform to support shared VMDK for Windows Server failover cluster. This technology is supported on Stretch Cluster and may be combined with availability groups. It requires virtual hardware or compatibility mode to your VM to be set to version 11 and requires SCSI bus sharing to be set to physical tall SCSI controller that will be used to connect your shared disk. We're also fully supporting migrating from on-premises failover cluster instances with physical RDMs to VMware Cloud on AWS, where you would convert it to shared VMDK on VMware Cloud on AWS vSAN. So that means that all your SQL Server high availability option created on premises could be migrated one-to-one to VMware Cloud on AWS. That reference architecture quickly shows you how to locate your 2-node SQL Server always-on availability group cluster within storage cluster on VMware Cloud on AWS. You want to leverage DRS anti-affinity rule as the same manner as it will be on-prem. In VMware Cloud on AWS, this feature will be called compute policies to ensure that your nodes will be located inside of different availability zones under the normal operation scenario. Let us take a look at SQL Server workload migration. We already learned that we can leverage either vMotion, normal vMotion process initiated from vSphere client, or hybrid cloud extension to migrate your virtual machine hosting SQL Server workload. But what about your SQL Server workload itself? If you will be migrating standalone SQL Server instance, you want to ensure that all prerequisites, especially networking, are already configured in place. Then you would be using long-distance vMotion from vSphere client. For low-loaded system, it might be live migration. For high-loaded system, you might want to plan for downtime because vMotion might have slight performance impact on your workload. And a very important thing to check all application consuming databases prior to vMotion and after moving to cloud to ensure that all your application components are located inside of the same data center. For SQL Server Always On, it will be looking at a SQL Server Always On availability groups cluster. After checking all the prerequisites, we recommend to change database replication to be asynchronous, then start migrating with secondary node first. After that, you will fail over to secondary, then you will migrate primary. If you have multiple secondary, you probably want to migrate all secondary nodes and finish your migration, handovering your primary node to one of your secondary, and then moving your primary nodes. After all nodes move to VMware Cloud on AWS, reconfigure your replication from asynchronous to synchronous to match your RTO and RPO requirement. For your post-migration configuration, that is where you would be preparing for your operational part of SQL Server workload on hybrid cloud. Check your application dependencies. Ensure that there is no additional latency between your application components after you moved your database to cloud. VNI, Visualized Network Insight, is a primary tool to check your network traffic dependencies, and it's supported with VMware Cloud on AWS vCenter. Ensure that all required compute policies are recreating your anti-affinity rules so that your nodes of your availability groups cluster or FCI nodes will stay separate, running on different hosts in different AZ if you're leveraging such cluster. Recheck your storage. Ensure that right storage policies are assigned. And recheck your NUMA. Recheck your NUMA configuration so that what you're having on premises will be also fit to what you're having in VMware Cloud on AWS. And recheck your database replication to make sure that it's reconfigured back to your expected RTO and RPO. Moving further, that is one of major questions that we are having while moving to public cloud. What is about my supportability? From the supportability perspective, the same rules apply as to your on-premises deployment of SQL Server workload on VMware vSphere on-premises. SQL Server is fully supported to run on virtual environment, on a hypervisor supported through the SVVP program, where VMware is listed starting with ESXi version 2.5 already for more than 10 years, and ensuring that all latest versions of VMware vSphere, including 6.5 and 6.7, are listed as supported version. And as the same version of vSphere will be used inside of VMware Cloud on AWS, the same supportability rules apply. It's no limitation or special certification process for VMware Cloud on AWS. From the licensing perspective, the same rules for licensing SQL Server workload on hypervisor applies to your VMware Cloud on AWS, meaning that you either can license based on number of vCPU assigned to a VM hosting SQL Server workload, or you might want to license an entire hypervisor host, licensing all cores, and in combination with software assurance that will allow you to run unlimited number of VM hosting SQL Server workload on top of such licensed hosts. Remember that software assurance is not a requirement to move your workload to VMware Cloud on AWS. It's still recommended to have software assurance from many different perspectives, as it also gives you an access to a newer version of SQL Server. But if software assurance is not available, you still can move such SQL Server instances to VMware Cloud on AWS and leverage in-guest licensing for that use cases. We are providing a bunch of documentation, migration guide, best practices guide, and performance guide for comparing different scenarios for running SQL Server workload on VMware Cloud on AWS. And I encourage you to recheck these resources after that webinar if you would be having additional questions. Quick note that we will be taking your question after finishing the main part of our webinar. And now it's my pleasure to hand over to Bill Jacobi. Bill.
Thank you, Oleg and Andrew earlier. So I'll be talking about Microsoft SQL Server workloads on VMware Cloud on AWS, and specifically the AWS components that would integrate and can integrate to create a better together solution with the VMware components that Oleg was talking about. Okay, so I will talk about a number of items, and you can see on this diagram, this may look a little complex, and I'm going to take this diagram and build it up one piece at a time. I'll be covering networking, Active Directory, setting up a Windows Server failover cluster, setting up load balancing for the application, DNS backup, monitoring, and similar areas. Okay, so I do just want to say sort of right at the outset that in terms of who delivers and supports VMware Cloud on AWS, it is VMware. So although it runs on AWS Global Infrastructure, VMware sells, delivers, and supports VMware Cloud on AWS, and billing is between you and VMware. And you don't need a separate support contract to run VMware Cloud on AWS. VMware Cloud on AWS is fully supported on VMware. Okay, so I'll just say, let's sort of jump into this diagram a piece at a time. Okay, and so when you start out on VMware Cloud on AWS, this is the configuration you would get if you just simply installed the environment and connected it to AWS. You see VMware Cloud, the VMware Cloud Virtual Private Cloud, VMware Cloud VPC on the right, and it leverages hosts coming from the AWS EC2 service, Elastic Compute Cloud service, and it provides an ESXi hypervisor, along with NSX networking, which provides interconnectivity in the middle piece there through a VMware Cloud Elastic Network Interface. This provides a 25 gig connection between the VMware Cloud side of the cloud environment and the AWS customer VPC side of the cloud environment. And both of these halves of the brain, if you will, are both running in the same AWS region, and they're two connected VPCs. So, like Andrew said, how is VMware Cloud on AWS deployed? Well, it runs on dedicated single-tenant hosts, which is why the licensing is essentially mirrors running Microsoft software on single-tenant hosts. They are dedicated hosts, not multi-tenant hosts, in a single account. And each host is equivalent to an Amazon EC2 i3.metal instance. And I think Oleg mentioned this. These i3.metal instances consist of 2 sockets with 18 cores per socket, 512 gigs of RAM, and 15.2 terabytes of raw SSD storage. So each host is capable of running many VMware virtual machines, tens or hundreds, depending on the requirements of each virtual machine. And you can set up clusters that range from a minimum of 3 hosts to a maximum of 16 hosts. And a single VMware vCenter server is deployed for each SDDC environment. Okay, so this is the basic starting point that you see on this slide. And the next thing that I'll add to the architecture is adding connectivity, adding interconnectivity to on-premises. And so if you can see the little green icon in the middle, that's a virtual private gateway. And the virtual private gateway is using either VPN or a service of ours called Direct Connect. I think I'd build these on the next slide. But the virtual private gateway is the software gateway that gives you access to on-premises. And the virtual private gateway is the target of how you set up Direct Connect or VPN to enable things like vMotion and HCX. So a VGW or virtual private gateway is the next architectural component. Okay, and like I said a second ago, Direct Connect or IPSec VPN is what you would run to the virtual private gateway. Direct Connect is your own private dedicated network that you would set up typically with a telecommunications provider and doesn't traverse the internet. It's your own dedicated network connection to AWS. Most of our larger enterprise customers have Direct Connect. And you can buy Direct Connects in 1 gig or 10 gig directly from AWS, or through telco providers. You can buy smaller pieces, smaller pipes. You can also use just simply IPSec VPN that would connect your AWS cloud environment to on-premises over the public internet. Using IPSec, you'll be encrypting each of the packets. Okay, so let's so now you've set up connectivity. So the VMware Cloud ENI in the middle is how you have connectivity between the VMware Cloud SDDC and your AWS customer VPC. The virtual private gateway, along with Direct Connect and VPN, is how you connect the entire cloud environment to your on-premises environment. Okay, and so the next sort of technical step in deploying SQL Server is setting up Active Directory. And AWS provides a service called, which you can see in the very middle of the slide, AWS Directory Service. AWS Directory Service comes in a number of flavors. It comes in one flavor called Managed Active Directory and another one called Active Directory Connector. Managed Active Directory is a flavor or a feature of AWS Directory Service in which Amazon is standing up Windows Server 2012 R2 machines sort of in the background that are running domain controller software on your behalf. And so if you go to the AWS console or the command line interface, you can configure Managed Active Directory, and that will give you Active Directory set up in a multi-availability zone configuration, providing directory services to VMware Cloud apps on the right side and AWS apps on the left side of this AWS region. And so Managed Active Directory is a service that simplifies the directory aspect of running SQL Server or any set of Microsoft applications, because you simply say, well, I would like to have 2 domain controllers highly available spread across availability zones. You could say I'd like to have 10 domain controllers, whatever number you pick. Amazon will provision those domain controllers, set up Active Directory sites and services, set up Active Directory DNS for the entire cloud environment, and essentially you get Active Directory delivered as a service with patching, with replication, with high availability, and it really just lights up Active Directory. Now, Managed Active Directory also supports, you can see the little tiny number 4 on the diagram. Managed Active Directory also supports 1- or 2-way trusts with on-premises Active Directory. And so a lot of customers want to treat the cloud as essentially a resource domain, which would mean you may want to set up a 1-way trust between the cloud directory and your on-premises directory. You could also set up a 2-way trust relationship, which would allow you to put users hosted in the cloud as well as have users hosted on premises, users and groups. And then you could assign permissions on either side, either on premises for access to cloud resources, or you could have users in the cloud who you can assign permissions to resources on premises. So you have full flexibility with being able to set up a 1-way or a 2-way trust relationship. I don't show it on my diagram here, but you also could have a single on-premises Active Directory domain that you've simply extended to include the cloud. And that would be using the other flavor of AWS Directory Service called an AD connector. I don't have that on the diagram here, but that is also an equally valid option. Okay, so I've shown here that when you turn on AWS Directory Service Managed AD, what we do in the background is we set up these 2 domain controllers on your behalf. These aren't sandbox open source Active Directory implementations. These are real Windows Server machines running ADDS. Okay, and so you have Active Directory across the availability zones in which you're running both VMC and AWS. So these are highly available domain services. Okay, and that takes us to sort of the heart and soul of SQL Server always on. Once you have Active Directory services set up, you can then set up SQL Server, and SQL Server runs really well on VMware Cloud because, like I said earlier, VMware Cloud through the hosts that are provisioned supports very high-speed storage. These NVMe-based SSD storage volumes provide extremely high performance for SQL Server. And the configuration that I'm showing on the right side of the diagram here is a stretch cluster, which means that each of the nodes or each of the hosts in your SDDC in this example are running in 2 different availability zones. So what this means is that you have high availability across the entire cloud environment. Whether you would have a failure in AZ2, you would be able to fail over to AZ1 if you look at the right-hand side of the diagram. Conversely, if you had a failure in AZ1, you could fail over to AZ2. And SQL Server will be resilient to a failure through the always-on architecture. I just want to remind you about what Oleg said a few minutes ago about how you would migrate your existing SQL Server into this environment. You would typically migrate the secondary first, set up SQL Server always on between a secondary on AWS and a primary that would still be on premises. And then once the secondary was on AWS, you would fail over that secondary to become the primary, and then you would fail over the remaining node on premises over to VMC on AWS, and you would end up in the configuration that I'm showing in this diagram. You could also remain in that hybrid on-premises cloud environment if you wanted to set up SQL Server to be a hybrid between on-premises and the cloud. And you would still have high availability. You would have to be concerned about do you want to set up synchronous or asynchronous replication between on-premises and the cloud? And typically the answer to that question would be you would set up asynchronous replication because of the latency. And when you have more than about 10 milliseconds of latency, then your application will slow down if when an application writes to the primary, it won't return successful until it's also written to the secondary in a synchronous replication scenario. And so typically, if you have more than 10 milliseconds of latency to your on-premises SQL Server, you would set up always on with asynchronous replication. For the sake of showing like a simple reference architecture, I've shown both nodes migrated to VMware Cloud on AWS. Okay, using a stretch cluster across multiple availability zones. Okay, now the next piece is, well, how do you know when to fail over? When there's a failure on node 1 or on node 2, the primary or the secondary, how do you detect that failure? And the way you detect that failure is by setting up a third instance that's running either SQL Server or running a file share witness. And in the example I'm showing here on the slide, number 7 here, I've set up a file share witness on the AWS side in a third availability zone, not AZ1 or AZ2, but actually AZ3, so that if there's a failure in AZ1 or AZ2, it doesn't take down the file share witness, and it can serve to provide quorum, I should say, and identify that a particular node or availability zone is offline, and let's initiate failover to the availability zone and node that remains online. So that file share witness can be running on just a file server, or you could use the Amazon FSX SMB file server service. So FSX for Windows is an SMB file share, highly available file sharing service in which you're setting up SMB shares across availability zones. I'm showing the file share witness simply in AZ3, but if you use FSX, it would span AZ3 and AZ1. Or you can just set up a file share witness on just an EC2 EDS volume. Either one of those will work. Okay, so you almost have your full. So at this point, you essentially have always on with your primary and your secondary and your witness. And it's not in the slide here, but the listener is also supported through DNS integration between AWS and VMC. And so we're using, I think I have a slide coming up that shows it, but we're using Route 53 as an overall cloud DNS, providing global DNS services for the cloud environment, and it's also extended to the internet. Okay, so next, after you've deployed always on in SQL Server on the right-hand side of the diagram, I'm showing an example here in which it's really hard to read, but number 8 in the very middle of the slide here shows elastic load balancing. And there are multiple AWS services that provide load balancing where traffic would come in, hit a load balancer, and then hit an array of application servers in either on premises or in the AWS environment or in the VMC environment. And the load balancer that I'm showing here in number 8 would distribute traffic to those say web front ends. Okay, so that's and that load balancer can be on the public internet, or like in my diagram here, it could be connected only to users who are on premises. Okay, and I've now added in Amazon Route 53, which is our global DNS service. And the global DNS service will allow you to resolve names like the name of the Elastic Load Balancer or the names of any of the web servers or the DNS listener if you wanted to point an application directly to the listener and have it resolved to either node 1 or node 2. Okay. The next piece I've added in are the applications. This is what I mean by app over OS, and I've got apps running on an operating system either on premises or on the AWS side where SQL Server apps are running on EC2 instances, or the applications may as well be running on the VMC side, and all of these apps will consume Active Directory through Managed Active Directory. They'll consume DNS through Amazon Route 53. If they need load balancing, they'll point to the Elastic Load Balancer I mentioned a second ago. And so what we're doing here is tying together Amazon services and VMware Cloud services. And because network connectivity is so high between the VMware Cloud VPC and the customer VPC, this hybrid cloud acts like a single environment where each side can reference the services of the other. Okay, and I'm just about at the end of the sort of full reference architecture, but Amazon S3 over on the top, number 11, is an inexpensive object storage that you can use for storing SQL Server backups. Object storage is about 1/10 of the price of EDS volume, and it just represents a very low-cost service for storing files. And those files, through a lifecycle policy, can be automatically rotated to a service I'm not listing here called Amazon Glacier, where, again, it's about 1/10 the price of S3, and it's essentially cold storage where it'll take either 5 minutes at the quickest or several hours to restore backups from Glacier. So there's a hierarchical storage system on the Amazon side. EBS volumes would be the highest performance volumes. Amazon S3 would be object storage, and Glacier would be cold object storage. Okay, and finally, I'm adding over here on number 12 in the middle of the diagram, CloudWatch, to be able to monitor a number of things. CloudWatch will monitor actual applications, so you can push CloudWatch. You can push to CloudWatch SQL Server logs, application logs, security logs. Anything that runs at the application level, those logs can be pushed up to CloudWatch. As well, CloudWatch has all of the AWS services support CloudWatch logs as well. So if we're running Amazon FSx or if we're running AWS Directory Service, all of these services create logs that can be pushed up to a central log repository in S3, and CloudWatch can handle the overall management and unification of logs across these different applications and services. And that gives you an ability to monitor the overall environment. Okay, and that really ties together this is the entire reference architecture that I started with, and I wanted to decompose it into the pieces that I walked through. I won't mention each of the pieces 1 through 12 here, but these are the pieces that I pulled together as I just walked through each of the slides. Okay, and so I think Oleg already mentioned licensing and supportability, where you're covered really in both areas. So I don't want to cover this again. I will just reinforce the fact, because it comes up a lot, that you can use either SQL Server licenses from on-premises that you've purchased from Microsoft, and you're fully licensed. If you're licensed on premises, you're also fully licensed to use those licenses on VMware Cloud. You don't have to have software assurance, like the slide says. There are many benefits of software assurance which are beyond the scope of this this webinar. And this environment is fully supported by VMware, by AWS, and even by Microsoft. Okay, so with that, I'm going to turn things back to Andrew for a wrap-up.
All right, Bill, thank you for that wonderful and very detailed architectural walkthrough, and Oleg for all the great SQL Server technical information there. I'm going to close this up with a couple of final thoughts here. As we wrap up, when you're looking at Microsoft SQL Server workloads on VMware Cloud for AWS, this is your fastest path to getting those workloads to the cloud. It's a very low-risk lift and shift migration using vMotion that is already riding on a proven VMware stack in your software-defined data center that is extended to the #1 public cloud infrastructure provider of Amazon Web Services, but also gives you access to over 160 native AWS services like S3, like Route 53, like RDS, and all the other services that Bill highlighted in his section of this presentation today, and obviously full support for SQL Server high availability. So as next steps, if you want to learn any more information, contact your AWS or VMware representative for a proof of concept or pilot. We've also got a list of resources that you can pick up after the presentation. We'll make these available. So lots of good info here. And next steps, if you want to talk to an expert, you can hit this URL, or if you want to look at a TCO model, you can meet with one of our cloud economists or use the VMC Sizer and TCO calculator, or if you'd like a hands-on lib. So with that, I want to thank everybody for their time today. We really appreciate you coming. And if you have any follow-up questions, leave them in the chat for us, and we will be sure to get back to you. Have a great day. Thank you.